Solution concentrations. What we are looking at is to define some of the things in the math terms in figuring out concentration of solutions. So the first thing we look at is mass percent, and that's the ratio of the units of the solute to the mass units of the solution. So the mass of the solute over the mass of the solution times 100 gives us a percentage of concentration. Some things that we can know to simplify our lives. 1 milliliter of water is 1 gram of water. 1,000 milliliters of water is a liter of water, which is also 1,000 grams. So if we assume that solutions with water as a solvent have a density of pure water, it's not perfect, but it works in most cases. So we'll use that 1 gram is equal to 1 milliliter. Molarity is the big one that we need to look at, the capital M. And that's what we've seen in multiple labs, that we have this big M. Well, molarity means moles of solute per liter of solution. And it's an important one that we have to look at. So anytime we see big M, it means moles of solute per liter of solution. So if we have this problem, how many grams of sodium chloride are needed to prepare 150 or 1.5 liters of a 5 molar sodium chloride solution? The first thing we need to ask ourselves is how much, what volume are we looking to prepare? In this case, the problem tells us 1.5 liters. And then we need to figure out how strong, what is our molarity? Our molarity is 0.5 moles per 1 liter. And then we need to look at what does it weigh? The molar mass. What's the molar mass? So the molar mass of sodium chloride is 58.44 grams. And so if we cancel out our units, we're left with grams only, and we'll see that we need 43.8 grams to make this solution. When we look at serial dilutions, and this is taking a stock solution and making it weaker, less concentrated. So we have a stock solution of hydrochloric acid, which is 1.6 molarity, and we need to prepare 250 milliliters of a 3 molar solution. So we can use the formula, the molarity of the stock times the volume of the stock is equal to the molarity of the diluted solution times the volume of the diluted solution. Or sometimes I simplify this to M1V1 is equal to M2V2. Your volume doesn't have to be in liters. I just did it in the problem this way. Substituting and moving everything around, we'll find what the volume of the solution is.